Chapter 11, Solving Equations. Name, number, oops, it's not January, date. Okay, so here are the three major learning intentions for Chapter 11. Solves equations by modeling and applying the preservation of equality, explains the difference between an expression and an equation, and models and solves linear equations problems. In order to be able to do this, the things that are required for you in this chapter, there are a few things that you need to remember. You need to remember the order of operations. PEDMAS. And remember, like we did it before, it's not division and then multiplication or addition and then subtraction. It's parentheses, exponents, which we're really not going to be dealing too much with, and then division and multiplication left to right, and addition and subtraction left to right. Why are division and multiplication and addition and subtraction on the same line? Yeah?
Because you do them together.
Because you do them together, but why do you do them together?
Oh, because they're different sides of the same coin.
Exactly. They're two sides of the same coin. You can take a division question and turn it into a multiplication question. You can take a multiplication question and turn it into a division question. And knowing that and remembering that is going to be really important when you're solving equations here. So I can do, for example, 2 plus 3 equals 5, and 5 minus 2 equals 3, 5 minus 3 equals 2. Same numbers, same concept, different ways of writing it. I can do 2 times 3 equals 6, 6 divided by 2 equals 3, 6 divided by 3 equals 2. Same numbers, same concept, different ways of applying it. So remembering this is going to be really important when you're solving equations. And then the other thing, one of the other things that you're going to have to remember with this is working with formulas. And when we talk about formulas, we're talking about things like, how do you calculate area? How would you calculate the area of something?
Length times width.
Right, so area, we've got variables to represent this. A equals length times width. And then if in our drawing we know these numbers, or at least a couple of them, if we know that this is 14 centimeters and this is 6 centimeters, we can substitute those numbers into our formula and determine area. So in this case, area equals length, 14 centimeters, times width, 6 centimeters. That is going to equal 2484 centimeters squared. That's going to be really important. You need to remember to put the correct unit. This is not centimeters. Area is always centimeters squared. But let's say that we didn't know what 6 was. We didn't know the width of our rectangle, but we did know that the area equaled 84 centimeters squared. Using this formula, we can figure out what that equals, because 84 centimeters squared equals 14 centimeters, we know that, times width. So how would we figure out what the width was? Going back to order of operations, we have 14 times width equals 84. What's another way of reworking these numbers in order to give us the answer that we want, the missing number? Yeah.
The area divided by the length.
Yeah, area divided by length equals width. So 84 centimeters squared divided by 14 centimeters equals width. So now we've isolated our variable, it's separate. And through our calculations, and we already know what the answer is because we did it the other way first, but through our calculations, 84 divided by 14 equals 6 centimeters. So we can figure out what the answer is. And then the final part of what you need to know is basically Chapter 10. It's understanding number patterns, understanding shape patterns, understanding how to figure out an expression in order to describe a pattern. Do you have any questions at this point? So in the first lesson, we're focusing mostly on expressions and equations. It's some stuff that we've done before, identifying constants, numerical coefficients, and variables in expressions and in equations, and describing the difference between an expression and an equation. And when you do this in your math journal, you're going to have to use words and examples to show the difference. Okay? As always, you're going to have to show your thinking. This is something that we need to work on a little bit. So what is the difference between an expression and an equation? Mitchell.
An expression is like one side of the equal sign and can have variables and stuff, and then an equation, all of it's known an equal sign.
Yeah. So the expression is one side of the equal sign. It can have constants and or variables and or numerical coefficients. Can it have a numerical coefficient without a variable?
No. Yeah. No. Yeah.
Okay, the people who say yes, why?
Because
Yes.
you can go like say you can go 6 times whatever, which is the numerical coefficient, and then plus a, which would be the variable.
Okay, that is a good point. I should rephrase. Can you have only one numerical coefficient in an expression? Why not? What's a numerical coefficient? Yeah.
Usually, if it's an expression, it would be the number without like the letter beside it.
That's the constant.
Oh, that's
The constant is the one. So if we use all three of these, this is the numerical coefficient, this is the variable, this is the constant. Okay? So in this case, the numerical coefficient is connected to a variable. What else could a numerical coefficient be connected to? Or this type of operation? Another number. So you could have 2 times 4 plus 6. Can you just have 2 times?
No.
No, you need something. So it has to attach to something. What about the constant? So the numerical coefficient, remember, you're multiplying or dividing. Usually a variable when we're talking about numerical coefficients. The variable, that's the unknown number. And it can change in an expression. It can't change in a equation. Why can't it change in an equation, but it can change in an expression? Yeah.
Because in equations, you're supposed to know all the numbers.
Sort of, yeah. You may not know them all at once, but there's only one correct answer. An equation is like a balance. Okay? One side has to equal the other side. Right? If I have 4 here, I have to have something that has the same value on the other side. So I could have 2 plus 2, or I could have 2 times 2, or I could have 4, or I could have 8 minus 4, or I could have 6 minus 2. There's a bunch of different things that I can use to equal this, but it has to equal. That's what an equation does. It balances out. So if I have on one side, let's go with 4 again. If I have 4 on one side of my balance beam, and I have 1 plus a variable, in this case 1 plus a, there's only one correct answer for a, because it has to balance out. What does a have to equal?
4.
Yeah, 3. So a has to equal 3. There's no other answer in an equation, but in an expression, I don't have a balance beam. I just have one side. So I can have 1 plus a, and I can replace a with anything. I could have a equals 1, and in this case, what would my answer be? What would the other side, my equation be? Yeah, 2. Okay, so then I would have an equation that is 1 plus 1 equals 2. If a equals 4, what's my equation? Yeah.
1 plus 4?
1 plus 4 equals
5.
5. Okay, notice we have to have that balance. So the difference between an expression and an equation gives you both sides of the balance beam, which means there's only one answer for your variable. In an expression, you're not given the other side of the balance, so you change the other side to suit whatever you're making your variable be. If you're making your variable be 1, then the other side of the balance is 2. If you're making your variable be 4, then the other side of the balance is 5. Okay? So if I draw an image that looks like this, what is the equation or expression? Is this an equation or an expression?
Expression. Or no, actually that one's an equation.
This one's an equation because I have both sides. So what is being modeled here? What equation is being modeled here?
15 plus 3.
No. That is not what's being modeled here. Yeah.
Wait. Can it be variable? Yeah.
Well, are there, in the picture, this is the thing, you need to look at this picture. In this picture, are there variables?
Yes.
Okay. Is there, what? Yeah.
It would be like a number divided by 3 plus 3, right?
I don't
Oh, wait,
understand
never
where
mind.
you're thinking.
Never mind.
3
No.
times.
Okay.
Forget that.
Yes.
3 times C, yeah, 3 times C plus 3 equals 18.
Attention, please. It will be a choice state.